Now see, here we have done ray optics in previous chapter. There we have assumed geometry of straight lines. That means we have considered light travels in the form of the ray, and some macroscopic phenomenon of light like a reflection, refraction has been explained by assuming light travels in the form of the ray. Now some microscopic phenomenon like interference, diffraction and polarization cannot be explained by assuming that the light travels in the form of the ray. So, in this chapter we will discuss the wave nature of the light. It means here it is considered light travels in the form of the wave. It was explained by Dutch scientists like Mr. Huygens. He explained all these things, that is the wave nature of the light. Now, in the wave nature of light, main phenomena which are going to discuss, that is the interference, diffraction and polarization. See here, light is a form of energy which travels in the form of the transverse wave motion in a medium, and when light travels in vacuum, it travels with the speed of the 3.3 into 10 raised to 8 meter per second. Now, here in the wave optics, first topic is here, that is first one is wavefront. So, first we will see here what is wavefront. Suppose you have taken a point source which sends out radiation or disturbances in all directions like this. If the medium is same, then all these radiations travel the same distance in the same time interval in all directions. Suppose distance travelled in time t is equal to c into t, then we can write, by taking the radius d is equal to c into t, we can draw a sphere, and this sphere, all the particles of this sphere has got same phase. It means the locus of the particle vibrating in the same phase is known as wavefront. We can draw the another wavefront like this. So, one important thing is here also, the rays are perpendicular to the wavefront. So, if the wavefront you are taking in this way, rays are perpendicular to the wavefront. Now, we will see different kinds of the wavefront. So, now see different kinds of wavefront. First one we will discuss here, that is a spherical wavefront. So, in this case, first one is spherical wavefront. Here the source of light is a point and radiations are like this. So, this type of the wavefront is known as spherical wavefront. In short, it is written SWF. Another one is here cylindrical. Cylindrical wavefront. We write here CWF. For this, here we can write CWF. We have to take not a point source, we have to take a linear source of light. So, for the cylindrical wavefront, suppose you're drawing the shape, it will be coming like this. There is a linear source of light. Every point of this source act as a new source of disturbances. If you draw the wavefront at this point, this is actually here spherical like this. So, by taking the different points you draw the spherical wavefront and join their tangent. So, this one is known as here now cylindrical wavefront. So, now see the third one is here the plane wavefront. We can take the plane wavefront, third one, that is here plane wavefront, that is written PWF. If the rays are coming from infinite like this and draw the wavefront like this. So, this is taken here as a plane wavefront over here. So, there are the basically three types of the wavefront, like a plane wavefront, cylindrical wavefront and spherical wavefront. Now, we can see here some other types of wavefront also, like if the suppose this is a point source here, the rays are going like this outward, then this type of the wavefront is known as here diverging wavefront. Diverging wavefront. Suppose the rays are converging at a point like this, then we can call it that is a converging wavefront. So, these are the two other types, and also for the plane wavefront we can draw like this, like this lines, and this one is also taken as PWF, that is called the plane wavefront. So, we can also discuss these three types of the wavefront, converging, diverging and plane wavefront.